is Michael, and we're going to be going through an instructor spotlight today where I kind of introduce you some things that interest me. I know this is the first spotlight that we're doing. So normally instructors like to talk about work that they've done in the past, but I kind of do something a little different with my spotlight. I like to talk about something that I struggled with a lot when I was first learning machine learning. And that is the topic of machine learning model selection. How do you know which model to choose when you're trying to solve a problem? It's not only something I struggled with back then, but it's something I always need to think about when I'm working on problems today. So this is never something that really goes away. So there's many ways to approach this problem of machine learning model selection, but I'm going to focus on just one aspect of it, and that is interpretability versus accuracy. Just know that there are other things to consider as well. So what are we going to do? We're going to talk about how we should think about choosing the right model for our problem. We're going to think about some problems that require interpretability. And then we're going to look at some other problems that are the complete opposite, where we only really care about accuracy. Great. So in this course, we've actually covered quite a number of models already. So, you can see this very nice list here. Of course, we've done logistic regression. We see that in almost every notebook. We've seen several iterations of neural networks. I'm sure in your projects, you've used some other methods as well. But we've only barely scratched the surface of the available machine learning models, in the 7 days we've covered so far in this course. There are a plethora of others. I only list a few others that we haven't covered here on this slide. Just know that there are endless possibilities. So the question becomes, if there are so many possibilities, what is the right choice for my problem? With that in mind, does anyone have any ideas of what you should consider when choosing your model? So I know the title of this presentation kind of gives it away in part with interpretability, that matters. But what other things matter when you're choosing models? Does anyone have any suggestions that they want to throw into the chat? Give you guys a second for that. Number of parameters, choose based on trends in the data. Yes, so I like both of these answers. How many parameters does your model have? I'm actually glad you mentioned that, because we are going to get into number of parameters a little bit later in these slides, based on the trends in your data. So, I think there's a lot of ways you can approach, what trends in the data really means there. But, I agree, like you always want to explore your data, kind of look at it first, get an idea of what it looks like, and the relationships that some of your variables might have, because that will drive you towards, how you're going to make decisions with what model is best. So those are both fantastic answers, and they are both absolutely things that need to be considered. Great. As you may know, we have some high interpretability models, and these are just algorithms that have very easy to understand or interpretable outputs. And actually, most of the models that we have seen in this course fall into this category. So the big one is, of course, linear and logistic regression. We also have seen decision trees. And all of these, very easy to understand, also tend to be easy to compute, but they don't necessarily have to be easy to compute to have an easy to understand output. And again, we favor these models just because, if we can understand what they're doing, it's easier to diagnose what's going on with our model. If accuracy is not that good, we can see why it's not performing well. Great. So I'm going to go into an example here of a project that I actually worked on. There's this very, very famous data set. It's a mushroom data set, and the goal of the data set is to predict whether a mushroom is edible or poisonous. I actually saw a lot of other people work on a project like this, and I saw people were using these really fancy models, like people were using neural networks, something else called like random forests. I'm like, great, you're getting great accuracy, but this this is the kind of problem where you really want to know why something is the way it is. I want to know why a certain mushroom is edible or poisonous. Why? Because if I go out into the wild, I need to know it. Any random mushroom that I find, I need to know if I can eat it or not. And, I'm not going to have my neural network in my pocket to tell me. So, it's always good to keep that kind of thing into consideration for certain types of problems. Great. So, what kind of model did I actually end up using to solve this? Well, it turns out that a very nice decision tree worked just fine. In fact, the decision tree performed just as well, if not better, I think, than some of the simple neural networks. And you might go, that's crazy. There's no way. But it just so turned out that it happened to work very well on the data, and that was fantastic. What you see in the orange boxes here are actually real features that I used in my model. So I think the most important thing to consider when determining whether a mushroom was poisonous or not is, does the mushroom have a really foul odor? And if it does, there is a very good chance that that mushroom is indeed poisonous. And likewise, you can also look for bruises on the mushroom because that gives more information. I do want to give a little disclaimer that the model that resulted from my efforts was a little more complicated than this. It was not just this very simple decision tree. It had a number of extra branches. So do not use this if you ever go into the wilderness one day. But this is just to give you an idea of what that output looked like. Great. So I think it's very simple to understand what the simple model is doing. So now let's kind of look at the other end of the spectrum. We have some models that aren't very interpretable. And the big one that we have seen in this course is, of course, the neural network and, all of its other components, such as the convolutional neural network. There's one other one I wanted to touch on. Again, we haven't really covered it in this course. You may have seen it in your project, may have not. That's called the random forest. And the reason I'm just drawing attention to this random forest model is because what a random forest is, it actually takes a bunch of decision trees. It combines them somehow. And of course, we know that the decision tree is a very interpretable model. So the reason I'm pointing this out is you can actually take a number of interpretable models and produce a higher accuracy but less interpretable output. Great. So before we really talk into why some of these networks are so uninterpretable, let's perhaps look at something that is interpretable, like linear regression here. So linear regression is very nice because there's only two parameters that we need to train, that being the slope and the intercept. And both of these happen to have very convenient outputs for us. So we know exactly what the slope means. So the slope tells us that, for every change in x by the slope, the y will change. And what does the intercept tell us? The intercept, also called the bias sometimes, tells us where it's going to cross the y-axis over here. So it's very easy for us to visualize this with a nice graph, and it's also very easy for us to verbalize exactly what both of those parameters mean. Now let's think of this in the context of a different type of model, such as the neural network. So, we said linear regression has two parameters, but how many does a neural network have? You can post some guesses in the chat, but of course, the number of parameters that a neural network has is very dependent on the neural network that you build. So let's just take a quick look at that. So we have a very simple neural network over here on the right. So it takes 50 inputs, and then it passes on to the first hidden layer, which has 100 nodes. Then another hidden layer over here, which is just a single node, a third hidden layer with another 100 units, and finally a 50-unit output layer. This is not a very deep or complex neural network by any means, yet it is still very complex in terms of our understanding as humans. So I wrote over here, this 3-layer network has 10,451 trainable parameters. So if you picked out any single one of those parameters, do you think you could tell me exactly what that means? And I would say, no. There are I should note there are some tricks to like perhaps visualize what some of the parameters are doing, but it's still not a fully understandable it's still not fully understandable for us to really know what's going on there, especially, there's no way we can understand what each and every single one of them is doing. And again, this was a very small network over here. There are other models. I don't know, you may or may not have heard of this, this language model called GPT-3. This model has over 175 billion parameters in it. In fact, I think there's some neural networks out there now with like trillions of parameters. So again, just to stress, like there's just too many parameters for us to understand what they're doing. We can't really interpret or diagnose something like that. So, taking a step back, I told you guys, I said both decision trees, linear regression, and logistic regression, they're all interpretable. So if that's the case, how would you know which one to choose? So does anyone have any ideas for this? What would you do? Now, if we have all these models that are interpretable, how would you choose which of those 2 or 3 you should use? Any ideas? Try both, see which has the higher act. I'm sorry, I need to go back on this right here. Yes, so I am very glad you said that because that, it was a bit of a trick question. Yes, that is exactly what you should do. And there's why not both? There's absolutely nothing wrong with training multiple models and seeing which one works best. That being said, when going into the problem, it's always good to have some kind of intuitive idea of what model you think is going to work best and how do you build that up, just by gaining domain knowledge. That's something that doesn't come naturally, it comes over time. So, it's good to experiment. I want to encourage everyone here to experiment with as many different machine learning models as possible and, see how the results of each of them, vary on different types of data. Great. So to get into my conclusion here a little bit, these are the key takeaways that I want you to come away with at the end of this. So you always, always, always want to start by understanding the problem that you are trying to solve. So how much does interpretability matter for that? And which algorithms do you think would help, find the answer to your problem? Next up. So I mentioned that interpretability is important, but it's not the only thing that's important. There are other factors to consider, such as the amount of data that you have or the time you have available for training. All these things need to be kept in mind on top of interpretability. So, there is a lot more that goes into model selection. Next, in general, if an interpretable model performs equally as well as a complex model, generally the more interpretable one would be preferred. And why? Because if something goes wrong, it's just easier to diagnose in that case. Why make the problem more complicated than it needs to be if your accuracy is going to be the same both ways? And finally, and I think the last one is the most important one here, there are no strict rules when it comes to model building. Everything I have said here are just guidelines to try to help you make informed decisions with choosing models in the future. But nothing here is a firm rule that you always have to follow for every single project. All right, so that's all I have for you today. I hope you got something out of it. Let me know if there are any questions, and thank you.